Welcome to IM1 10.5, video number 1 of 2. There are 3 boxes for us to talk about today, and our topic is finding the distance from a point to a line. Definitely heavy on the algebra for this lesson, but very doable if you follow along with me. Okay, so box number 1, there are 2 theorems that we need to know for this particular unit. The first theorem is something that you should already know, is that slopes of parallel lines are the same. That should not be a big surprise to anybody in the room. We've seen this before. So taking a look at our diagram over here, I have this blue line in M, and I have this red line over here, not M, sorry. And I know that these are parallel again because they have the markings that say that they're parallel. There's that red triangle again. And then down below, the M, remember M stands for slope. So the slope of line 1 is equal to the slope of line 2. And that's exactly what we're saying right here. The slopes of parallel lines are the same. That's the first thing we got to know, okay? The second thing we got to know is a little bit more interesting. Maybe you don't know this yet. Slopes of perpendicular lines multiply to -1. So they are opposite reciprocals and they multiply to -1. So let me explain this one a little bit better for you. I have this blue line here, over here, and then I have this red line over here. And they are sitting perpendicular to each other, which means they are at 90 degrees to each other. They're at right angles. And I know that because of that little red square right there. So if I take the slope of this blue line, and I multiply it by the slope of the red line, I am guaranteed to get a -1. That's really important. So the slopes of perpendicular lines multiply to -1, okay? And before we leave this box, I want you to remember the distance formula and write the distance formula right here in this blue cloud because we're gonna need it and we're gonna use it. So go ahead and do that right now. So you should have gotten this, the square root of x2 minus x1 quantity squared, plus the plus the quantity of y2 minus y1 quantity squared. So that's our distance formula. We're going to need that in this lesson. Okay, box number 2 is an example, and it's a pretty gnarly example, so please make sure you're paying attention and you're following along with me, okay? It says this is the main objective. Find the distance from a point on the line, from a point to a line. So we've been given a line, and the line is y is equal to -x plus 3. So to recall, to graph this line, I would go up to 3. I would go down 1 over 1, down 1 over 1, down 1 over 1, because my slope is worth -1. And obviously, I get this blue line right here. Then they gave us a point, and the point is 1, 0. So if I plot the point 1, 0 on the graph, which I have, what we're looking for is the perpendicular distance from here to there. So we want to get a perpendicular right angle from the point to the line. We're not looking for this distance or that distance or that distance or even this distance. The definition of the distance from a point to the line is the shortest perpendicular distance that we can create on the coordinate plane. So step 1 of all this stuff over here is to find an equation of the line perpendicular to the line y equals -x plus 3 and passes through the point. So what I'm looking for is the equation of a line that would be perpendicular here. So if it's perpendicular, I know the slope is going to be the opposite reciprocal of this. Okay? So I suggest you start by using point slope form. So y minus y1 equals m times x minus x1. That's called point slope form. We talked about that way back in chapter 1. So hopefully you remember. Plug in the points that you have. Remember, this is your x and this is your y. X always comes first, y comes second. So I'm going to have y minus 0 equals, okay, my slope of this line is -1. So the opposite reciprocal of that is just going to be 1. And then I'm going to have an x minus 1. And then I'm going to clean this up and solve for y. So it looks like y is going to be equal to 1 times x is just x, and 1 times -1 is -1. So there we go. That's step number 1. Find the equation of the line that is perpendicular to the line given. That's your first step, okay? Step number 2. It says write and solve a system of equations to find where these points intersect, or where these lines intersect, at what point. So I'll do this one for you. So we've been given the fact that we've got y is equal to x minus 1 from here, and we've been given the original equation, which is y is equal to negative x plus 3. That was from our original equation. And I want to know, where are they equal? So I'm going to set them equal to each other and solve. So I'm going to set x minus 1 equal to negative x plus 3 and solve for x. So I would add x to both sides. So x plus x is 2x, minus 1 is equal to 3. Therefore, 2x is equal to, if I add 1 to both sides, I would get 4 coming up over here. So 2x is equal to 4, divide both sides by 2, and obviously I would get x is worth 2. Okay, if x is worth 2, then substitute it back in to find the y value. So I'll use the first equation. Y is going to be 2 minus 1, so therefore y is going to be 1. So it looks like they are intersecting at the point 2, 1. And if I look on the graph, yeah, it looks like they're exactly intersecting right there at the point 2, 1. So that is step 2. Find where they intersect, okay? And now lastly, use the distance formula to figure out the distance from the original point, which is 1, 0, to the new point that we just found over here in step 2 at 2, 1. So remember, that's why I wanted you to write down the distance formula in that blue box. So our distance formula is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So plugging in, this is going to be my x1 and my y1. This is going to be my x2 and my y2. So just plug them in and chug along and see what you come up with. Okay, x2 is a value of 2 minus 1. We're going to square that. Y2 is 1 minus 0, and we're going to square that. So this is going to give us the square root of 2 minus 1 is 1 squared plus 1 squared. So I'm getting the square root of 1 plus 1, so I'm getting the square root of 2. All right? And the square root of 2 is approximately, if I plug my calculator in to get my calculator, so second square root of 2, and I would get about 1.41. So if it asks you to round to 2 decimal places, we'll go about 1.41. So what does this mean? This means that the distance from this point right here to this point right here is about 1.41 units. That's what we're finding. Now that's a lot to take in, so let me show you the whole box from start to finish, and that's what we need to be able to do in this lesson. So step 1, find the equation that's perpendicular. Step 2, set them equal to each other and see where they intersect. Step 3, use the distance formula. Okay, box number 3, we'll do one more example together. It says, find the distance from the point 6, 4 to the line y is equal to x plus 4. So I've graphed everything for you, and what we're looking for is the perpendicular distance at right angle. So we want to take that into account right there, okay? So number 1, again, is to be find the equation of the line that is perpendicular. So I suggest using point slope form. So I'm going to do y minus y1 is equal to m, and then a x minus x1. Okay, so the point that I have here, this is x, and this is my y. So I'm going to say y minus 4 is equal to, now the slope. The slope of this line is 1, so the slope perpendicular will be negative 1. Negative 1, and then x minus 6. Let's clean this up a little bit. Y minus 4 is equal to negative x plus 6. Therefore, y is equal to negative x plus 10. Okay? So that is the equation I just added 4 to both sides, and 6 plus 4 makes 10. So right there, that's my first step. I found the equation of the line that would be perpendicular to that red line over there. Step number 2, figure out where they intersect. So in a different color for you. One of the equations I have is y is equal to negative x plus 10. That comes from right here. The other equation that I have in pink is the original one in the problem. So y is equal to x plus 4. I want to set them equal to each other and solve. So that's what I'm going to do over here. Negative x plus 10 is equal to x plus 4. I'm going to subtract x from both sides. So negative x minus x is negative 2x plus 10 is equal to 4. I'm going to subtract 10 from both sides. So negative 2x is equal to 4 minus 10, which is negative 6. I'm going to divide both sides by negative 2. So x is going to be the number 3. Okay, so if x is 3, I'm going to plug it back in and see what I get. Y is going to be 3 plus 4, and that's going to be 7. So it looks like they meet at the point 3, 7. And let's look at my graph to see if that's even close, right? So here is the point. Here's 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7. Yep, they could totally meet right there. So again, 3, 7 is the location of where they meet. So now I'm going to use the distance formula from my last final one. So this is my first point, x1 and y1. And this is my second point, x2 and y2 over there. So my distance is going to be, again, the square root. x2 minus x1 squared plus y2 minus y1 squared. That's our distance formula. Let's plug in each of these. So the value of x2 is 3. The value of x1 is 6, and we're going to square it. Okay, plus the value of y2 is 7. And then the value of y1 is 4, and we're going to square it. So that's going to be the square root of 3 minus 6 is negative 3. We're going to square that. 7 minus 4 is 3, and we're going to square that as well. So it looks like we're getting 9 plus 9, which is the square root of 18. And that will be approximately equal to, if I plug in my calculator here, and ask it for the second square root of 18, I would get approximately 4.24. So again, what does that mean in context? It means that the distance from here to there, that little green highlighted point right there, is approximately 4.24 units, and that's what we want to be able to do. So there's the whole process, start to finish, with your 3 steps. Okay, nice job, everybody.